With sales forecasting, there are two broad categories of forecasting methods. Time series is where we look at past patterns to predict the future. It's been compared to driving down the freeway, looking in the rearview mirror, looking at the past to predict the future. Primarily in this class, we're going to focus on trend, and it's going to be a linear or a straight line trend, or seasonal patterns in the past, the 4 seasons affecting sales of many products, or a combination of those two, or the lack of either of those patterns, in which case we just want to predict a straight line in the future of what sales are because there's no pattern adjusting it. The other type of forecasting model is called causal. What we're going to do is look at other variables to predict the future, right? Causal models can start with a time series model. We can look at time as one of the factors. Regression is usually the tool that's used to develop causal models. And we'd look at other factors like GDP, oil prices, exchange rates, anything that we think may impact our sales. Marketing campaigns may be something that would affect our sales. As an example, let's look at forecasting for a college fraternity over a previous number of weeks. So we have the demand history. So week 1, consumption was 8 cases, 5 cases, 7, and so on. And what we want to do is predict future consumption values based on this past. When we're looking at the data, we're looking for a pattern. Now, it may look like a Western W here, but we really don't see any pattern. It's not a seasonal pattern. Seasons would be over a monthly period. There doesn't seem to be any trend. Maybe this is going up a little bit, but it's really too soon to say that that's a trend. So what we want to do is look at a model that would forecast an average value. We would look at that as our prediction and allow for the case that we may over or under forecast and adjust with that using inventory. Something like beer that can last from 1 week to the next. So we might forecast sales of 6 or 7 cases and have 3 on hand in addition as our safety stock, right? So if we want to do this, many ways are available to do this kind of forecasting. These are called smoothing models. We really just want a smooth forecast into the future. The moving average is one smoothing model method. A 3-period moving average simply averages sales for the most recent 3 periods and uses that as a forecast in the future. So we're taking sales of 3, 6, and 9 cases, adding them up, dividing by 3, getting an average of 6, and then 6 becomes our forecast into the future. So it's called the moving average forecast because we're going to take the most recent 3 periods, use that to forecast the future as far out as we think we need to forecast. Once we get new data, if we find out sales are 5, or consumption in this case of beer is 5 cases, our next forecast is going to move forward and take those next 3 values and use that to forecast. So when we get new data, we will update the forecast. One of the important considerations is demand versus sales. Demand is not always sales. Why is that? Well, you might have run out of the product. Fraternity might have run out of beer. They might have consumed more if it was available. That can happen in business. Your sales process and your information system, your enterprise system may be capturing sales, but it may not capture unsatisfied demand. If a customer calls up, your product's not in stock, they decide not to order, that may not be captured. Also, you may have demand coming in, say, the month of March. Also, you may have demand coming in the month of March, but you can't ship it to April. So your information system will record that as sales in April when actually the demand was in March. The problem is if you're not looking at demand, you're not capturing these cases where you are short, you're forecasting planned shortages. You're going to forecast in the future that shortage you had this year into the next year, into the next period. One of the things we can do with the moving average forecast is adjust the number of periods that we're using. So we could move to a 2-period moving average forecast. We would take just the latest 2 consumption values, latest 2 sales figures in a typical situation, average them together and get a forecast of 7.5, which would be our prediction of this data going forward. You'll notice that that's above a number of the data points. What this does is says these 2 data points are more indicative of what's happening than these data points here in the past. If we reduce the number of periods in the moving average forecast, we're going to have a forecast that's more responsive, that's going to look at this as a trend and start to try to get ahead of that or adjust to it a little more quickly. That may or may not be the right thing to do. As we reduce the number of periods, we're going to have a more responsive forecast. Here we can see with 3 periods, 2 periods, and 1 period, we're looking at this trend as a trend, or really this pattern. It's not a trend unless we see enough data to say that's really happening. Maybe it's a shift in our consumption and we'll be in a higher position. The 1 period moving average will respond to that quicker, but responsiveness is not always good. There are reasons that we wouldn't want to have a more responsive forecasting method. Here's an example of a forecast over a set of data. And if we look at a moving average forecast with 2 periods, this is a model, and this is taken from the scrimmage sim simulation. You can see that there's a lot of variability in the data. That's the blue line here. And our forecast, as you can see, varies over time quite a bit. So these orange borders are really the range of forecasted values as we go forward. This is problematic for a manufacturing facility because 1 week you're telling them to produce a high level, a few weeks later produce a lower level, rather than staying in the middle of this data. So in this case, having a very responsive model probably does not help your facility out. If you had a change or a shift, it might be better. It might respond more quickly and allow you to adjust more quickly. But along with that responsiveness comes a variability in period-to-period forecasts, and that's a negative for the manufacturing facility. You can look if we move to a 7-period moving average forecast. Now our forecast does not adjust so much. It's much more consistent if you look at the bounds of the forecast, much narrower. We're giving more consistent numbers to the production facility. Yes, we do have periods where we miss that, but we can't predict these. And what we have to do is say our average is around 5,300, and we're going to adjust with that by expediting, by safety stock, or some other method. So in general, too much responsiveness can create too much variability in our plans and make it more difficult to meet customer demand. Now what we'll do is switch over to Excel and look at how do we program this into a spreadsheet. Sometimes these formulas are a little bit complicated, especially as we move forward, so it's good to see how this looks in a spreadsheet, how we would program this. This is also a tool that then could be used in the exam in this course. In Excel, we can set up the moving average forecasting method fairly simply. We'll start down in cell A2 and put in the title week for which week we're looking at forecasting. And we won't put the date range as we did in the example in the course pack. We'll just start numbering them 1, 2, and again in Excel we can highlight these first 2 cells. We can drag that down. Let's go 10 weeks into the future. So we'll go in 10 weeks, we'll have 6 weeks of data, 4 weeks of forecast. The next column we'll put is actual. So actual sales or consumption values. And a third column we'll call forecast. To make everything look nice, we'll highlight everything and center it. We'll take the column headings, bold them, and also make sure we put a bottom border in. So now it looks reasonably nice. On our forecast, we'll put in a note n equals 3 for our moving average, just so we know the number of periods that we're forecasting. Turns out that while the moving average forecasting method is fairly simple, it's not really easy to adjust. We'll see that when we get to exponential smoothing, while the math may seem a little more complicated, it's actually a much nicer forecasting model to implement in a spreadsheet or in software. It's much easier to adjust. Next, we'll type our actual sales values, 8, 5, 7, 3, 6, 9. And now we can put in our forecast. So we need 3 periods of data to initialize the model. Our first forecast then can occur in period 4. And to do that, we just type equals average, highlighting the 3 cells for the first 3 weeks, And there's our forecast. It's got a few too many digits, so we can just go up and reduce the number of digits. We'll leave it at 2. We can then drag this formula down and see in period 7 our forecast is 6, just like in our notes. We can't continue to drag that down because it will be referring to cells without values, so that's not going to work. So beyond this, we'll type equals the previous value, the previous cell value, and then we can drag it down to the end. Excel gives us warnings about omitting adjacent cells. We can just tell it to ignore the error, and now we're set to go. Probably got to do it on this one as well. Sometimes Excel is a little bit too helpful in my opinion. Okay, now one of the things we can do is we can graph this forecast just to get a sense of it. We can select our data including the headings, click on Insert, and in Charts we're going to select the 2D line chart. And Excel almost gets it correct. Let's take it up here, make it a little bit bigger, and go to Select Data. So we want to tell Excel what we want for data and what we want for axes. We don't want the week to show up as a data point, so we'll just subtract that out. But we do want the category labels, the horizontal x-axis category labels, to be the week values. So we can do that for the actual. We can also check and make sure that's done for the forecast. And now we get something that looks a little bit better. So we can see in orange, we have the actual values, and in gray, we have the forecast. Excel likes to make chart titles and axes quite small, so one of the first things I do is select an axis, make the numbering a little bigger. Same thing for the vertical. Same thing for the chart title. And we can call this moving average forecast. We can take the legend, similarly increase the size of that. And we should probably know the units of measure for both the horizontal and vertical axis. So if we again are selecting the chart, go into chart design, we can add chart elements. So we can look at axis titles, the horizontal axis title, we can call that week. Delete out the default value there. And again, we should make that bigger. Go back to home, make the font bigger. Again, go to chart design, axis titles. We're going to do the primary vertical. And this is a weird thing about Excel is you have to use the up-down arrows when you're in this mode. We'll call this sales, cases. It's good to have the units of measure. It's good to spell it correctly. And we'll make this bigger again. And now we have a chart where we can see what our data was, what our actual consumption values were, and the forecasting model. And this period, weeks 4, 5, and 6, this is where we can compare the model with the actual results. The next smoothing method we have is the weighted moving average. If we look back at the moving average, we're adding up the 3 most current values for a 3-period moving average and dividing by 3. If we use the laws of algebra, that's the same as taking 1/3 times each of our values. In other words, we're weighting each of our values equally. They each have 1/3 impact on our final forecast. We think, generally, that more current data is more predictive of the future than something that happened farther in the past. So this 9 may be more indicative of what's going to happen in the future than this value of 3. So we may not want to just jump on the 9 and say that's our value in the future, a very responsive forecast. But we may want to shift the emphasis and increase the weight here on the more recent value and decrease this weight on the previous value. So rather than using an equal weighting, which the moving average does, we can get different weights and create a different forecasting method that balances responsiveness with having stable forecasts over time. When using the weighted moving average, a set of weights needs to be selected, and that's a bit of a challenge. It's a little bit fiddly. First of all, the weights have to be greater than 0 and less than 1 individually, each weight. Also, as a group, they should sum up to 1. So here's an example of valid weights, 0.5, 0.3, 0.2. And remember, the order of the weights listed isn't necessarily how they're used in the formula. In other words, if we were using these weights, the 0.5 would be applied to the most recent sales value or consumption value. The 0.3 would be used next, and the 0.2 would be used with the oldest data period. We'd be using 3 periods of data, but putting more emphasis on the more current one and less emphasis on the previous one. Here's another set of weights that are valid. We're putting even more emphasis on the newer data and much less emphasis on the older data. 1/2, 1/3, and 1/6. If we think about that, a half is equal to 3/6, 1/3 is equal to 2/6, and 1/6 is 1/6. So if we add those up, we're going to get 6/6. So that's equal to 1. Those are valid weights. Some invalid weights, 0.5, 0.2, 0.1, they add up to 0.8. And if we were to use those weights, we would be under forecasting over time. We would consistently having a bias towards forecasting low. Having a weight that's negative doesn't really make much sense. Here we have weights that add up to more than 1. So we would be over forecasting with that set of weights. We would be consistently forecasting higher sales or higher consumption values than we would have in practice. Here's an example of applying the weights 1/2, 1/3, 1/6. And again, we're going to take the 1/2, the biggest weight, and apply it to the most recent data value. We're going to take the 1/3 and multiply it by the next most current, giving that the next most emphasis. And the smallest weight is going to be applied to the oldest data point. When we take that weighted average, we get 7 as our forecast, which we would carry into the future until we find some new data. Then we would shift this forward, just like with the moving average, to adjust to the new data. Again, we want to apply the largest weight times the most current data and the smallest weight times the oldest data. Again, to better understand the weighted moving average forecasting method, let's create a spreadsheet that uses this method. Like before, we'll start off with some column headings: week, actual, and forecast. Under the weeks, we'll number these for simplicity. So I'll put in the first 2 numbers, highlight the cells, and then drag these cells down so that we have 10 weeks for forecasting. We'll center this. Actually, let's select everything and center all the values. We'll select the headings, make those bold and underline them. We'll put in some weights. So we're just going to put in values for the weights. Let's use 0.5, 0.3, and 0.2 for our weights. And again, we'll center these as well. We'll center this and bold it. And let's just put a box around that so that we can identify those as being part of the weights. Let's also put an extra line in here so that stands out a little better. There we go. Now, first we have to put in our actual values. 8, 5, 6, same values as in our presentation. 3, 6, 9. Now our forecast, we need 3 data values, the first 3 weeks of data, because we have 3 weights, to make our forecast in period 4. So I'm going to type equals, and I'm going to take this most current of the 3 weeks period, this most current value, times the biggest weight. Now when I select that cell, it's a relative measure. As I start to copy this formula down, C2 will be incremented to C3, C4, C5. I don't want that to happen. So on a Windows PC, I'd use the F4 key to make it an absolute reference. On a Mac PC, I use Command and T, and you can see that it inserts dollar signs into the formula. So cell C2 will always refer to that weight no matter where I copy that formula. I'm going to add to that the next most current data value multiplied by the appropriate weight. I'm going to use the Command T on the Mac or the F4 in a Windows computer to refer to that cell D2 wherever I copy that formula. Finally, add the oldest data value times the smallest weight. Use the Command T or F4 key to make that an absolute reference. When I hit return, I now have a forecast that's a weighted average of 6, 5, and 8. Like before, I can copy this down. I don't want to go past 7 because then I'm going to be copying 0 values for the actual data values. I won't get a valid forecast. To carry this forward, I'll just use equals this cell value. I can drag that down. And now I've got a weighted moving average forecast spreadsheet. I can graph this data if I want. If I want to change the weights, I can change them easily. If I want to change the number of weights, then I've got to change the formula. I've got to adjust this formula to add more or fewer weights. And so it's not a very convenient method to use because I have to think up weights. I have to think up weights to add up to 1 in a proper order. So it's a useful method for understanding how you might want to weight more current data heavier than older data. It's really not an easy to use method. That's why we'll look next at the exponential forecasting method. When we look at forecasts, we have to look at terminology to understand what we're talking about. A lot of times the confusion comes that we're talking about data in the past, data in the future, pretending as we look through this logic, what if I only knew a certain piece of data, what would I be doing? So really there are 3 periods when we look at forecasting, if we look over time. There's the initialization period. This is where we fit the model. This is where we take, for example, a 3-period moving average. We have to have the first 3 sets of data in order to forecast. Here we're showing what we'll eventually get to, which is a model which has both seasonality. This is monthly data, so we have 24 months. We have high demand in some parts of the season and lower demand. We also have a trend going forward. So to initialize this model, as we'll see later, we're going to need 24 pieces of data. Once we have the initialization done, if we have extra data, we can test the model. We'll be talking at the end of this section about error measures. And this extra data is where we make a forecast. That's what the red line looks at. We make a forecast, we compare it to the actual, and each time we update the model. So we have 1 year's worth of data. This is called the ex post forecast period, where we can look at measures of error. We can see how well would it do. In this initialization period, the data and the model should fit very well because we're fitting this data knowing the answers, kind of like taking an exam knowing what the answer is. The fit should be very good here. We also need to check and see if the fit is good in this period before we say that this actual forecast has any chance of being valid. If we looked at our 2 forecasting models, we have the 3-period moving average and the weighted forecast. Because we had 3 weights, we have 3 periods. The first 3 periods are our initialization period. We need that much data before we can finally forecast into the future. Because we have 3 extra periods worth of data, we have an ex post forecast region where we can make comparisons between our actual sales or consumption and our forecasting methods. And that's where we would get, again, error measures fun. Finally, our forecast is with the moving average 6 into the future, with the weighted moving average because there's more emphasis on the more current data and there's a bit of what appears maybe to be a trend. We have a higher value forecast into the future. To understand exponential forecasting, first we have to develop some notation. It's useful when forecasting to number the periods. So we see our first column. We're numbering the periods. This is just like the weeks that we were using in the spreadsheets. The sales are the actual consumption values, what we actually did. We used the notation A subscript T. So this 8 is A subscript 1. This 5 is A subscript 2, and so on. The forecast, for example, here we have forecast in period 7. If we're doing moving average, forecast in period 7, this value, is calculated by taking the actual values in periods 4, 5, and 6, adding them up, dividing by 3, and giving us our forecast value by 6. So it's not necessary for the moving average or weighted moving average method to use this notation, but it is useful and convenient for exponential smoothing. The exponential smoothing formula has some benefits over weighted moving average or moving average. It has the benefit of using weights, like in weighted moving average, but rather than using the cumbersome weights and having to figure out whether they add up to 1 and organizing them, exponential smoothing uses just one parameter, alpha. This alpha adjusts how responsive the method is. So when alpha is large, it's a more responsive forecast. When alpha is small, it's less responsive. It's slower to respond to shifts or changes in the data. The alpha value ranges between 0 and 1, and typically a useful value is in the 0.2 range. The formula says when we want to forecast one period or more in the future, we take this alpha value, multiply it by our previous actual sales value, and 1 minus alpha times the previous forecast. So the previous forecast can be thought of as an average of really all the data. If you look at it mathematically, what we think the level of sales is. Again, smoothing models assume no trend or seasonality. And we're going to take some portion of what we just saw. So usually if we use an alpha value of 0.2, we're saying the bulk of what our future forecast is going to be is what we thought we had in the past. But we're going to take some fraction of what we just saw and make a tweak or an adjustment to our forecast. One of the things with the exponential smoothing method is it always depends on a previous forecast. So you have to initialize this or start this method in some fashion to get your first forecast. There are different ways you can do that. For simplicity's sake, we're going to use as our initial forecast a forecast value in period 2, and we're simply going to add up our first 2 sales values and divide by 2. In other words, we're going to average the first 2 sales values. Here's an example. And again, let's look at the formula. The general formula for exponential smoothing is your forecast in period t plus 1 is going to be equal to alpha times the actual value of sales we had in period t plus 1 minus alpha times the forecast of sales we had in period t. So it's again a weighted average of what we just saw and what we've had in the past, our past history averaged together. So again, the weighted moving average formula is a weighted average. So the exponential smoothing formula is an average of what we just saw and really the history of values, the forecast value that we had that represents an average of all our data prior to that time. So if we're looking at forecast in period 3, because that's the first period in which we can actually do forecasts, our exponential smoothing model says the forecast in period 3 is going to be equal to alpha times the actual in period 2 plus 1 minus alpha times the forecast in period 2. And if we look what we have, alpha is given as 0.3 in this example. This is a parameter that you as the forecaster pick. Again, something around 0.2 to 0.3 is typically a useful value. We're using 0.3, so alpha, that's this part, times the actual sales we had in period 2. That came right from here. 1 minus alpha is 0.7 times our previous forecast, which we got as part of our initialization, just averaging our first 2 sales values to get a starting forecast. That gives us a forecast of 6.1. To forecast the next period, we'd wait until week 3 was over, and we'd find that we had sales of 7. We forecast 6.1, we see sales of 7, so the exponential smoothing method is going to say that we underforecast a bit, we need to make an adjustment. So with our smoothing parameter of 0.3, we're going to take 0.3 times the 7 we just saw. And the bulk of our forecast, we're going to stick with the 6.1 we had. Again, exponential smoothing says that we don't have any trends or any adjustments. We're trying to get in the middle of data that has variability. So the bulk of this forecast, 70% of it, is going to be the previous value, but we're going to take a little consideration that we under forecast and got our new forecast value. Again, once we find out, week 4 is done, we find out what our sales are. In this case, sales were 3, we predicted 6.4, so we over forecast. So our next forecast is going to take 30% of that sales value we just saw, which was significantly lower. Still 70% of the 6.4 we predicted, which results in a forecast of 5.4. We do this throughout the whole ex post forecast period where we have data. And finally, 6.6 is our forecast for week 7, our first true forecast, and that value we would carry on to week 8, 9, 10. We're going to forecast a straight line out into the future, and the only time we'll adjust that is when time moves forward and we get a new value for sales in week 7. To understand exponential smoothing, let's make a simple Excel forecasting tool. Again, in the first column, we'll put the heading week, actual, and forecast. We'll center those, make them bold, underline them, and we'll put the week numbers. These are the period numbers in our new notation, same thing we've used before. Put 10 of those in there, center them. Let's center everything else while we're at it. Actual values, 8, 5, 7, 3, 6, 9. And we're going to put in our parameter alpha up here at the top. Actually, I'll say alpha equals. We'll put in a value 0.3. And this is something that we can adjust. We'll center this, we'll center this, and we'll make this bold. Now, first we have to create our initial forecast. Let's highlight these first 2 rows so that we realize this is the initialization. I'm going to use the formula equals average of these first 2 cells. That gives us our first simulated or fake forecast. Now that the model's initialized, we just have to use the formula equals alpha. And again, we'll use the F4 or Command T function to say, I always want to refer to this alpha, times the actual sales we had in week 2, because we're forecasting week 3, plus parentheses 1 minus the alpha value. Again, the F4 Command T to always refer to that cell, close the parentheses, times our previous forecast. Again, that's an initialization value. It gets us our first forecast. And now we can just drag that formula down. And we'll adjust the number of decimal places so that we have a reasonable number. And we can see that we're constantly referring to cell C1, our alpha, and 1 minus alpha, always referring to the same cell. We're just taking the previous actual sales and forecast, weighting them together. We can bring this down by putting the equals previous cell value formula in. And now we got our exponential smoothing forecast. The advantage of this is that I can change this alpha value. I can go to 0.2. I can go to 0.5. I can adjust the responsiveness of this very quickly with just one parameter. So while the formula looks a little more confusing, it's actually pretty simple. It's fairly easy to use. It'd be useful to graph this forecast versus actual, play around with the different alpha values, and see how that alpha adjusts the responsiveness. Again, a useful value is typically around 0.2. Outliers are an important concept in forecasting. Outliers represent data that is unusual. For example, sales that increased or decreased because of weather, like a blizzard or a storm, or sales that are impacted by some other situation like coronavirus. When we have an outlier value, we think it doesn't represent what's going to happen in the future as much as our regular data series. Outliers can have a significant impact on the forecast value. You can see that depending on how responsive our forecast is, it's going to draw the forecasts up quite a bit higher. With an exponential value of 0.2, a pretty typical one, it will have a bump, a fairly significant bump, here almost 20-25%. If we have a really large alpha value, this is really higher than would be practical. We can see it can really drag those values up. Our forecast would be dragged up quite a bit higher. If we have an outlier, it's perfectly legitimate to adjust that value somewhere in the data where you would expect it to be without the extraordinary circumstance. Sometimes outliers can be the result of data entry problems. If we have an outlier, they can and should be adjusted, but it should be done with care. If you start adjusting out a lot of outliers, you're really just taking out the random natural variability of your data and really distorting your forecast. If you look at data that's an outlier, and especially if you have a cause for that outlier, it's perfectly appropriate and wise to make an adjustment to that data before you forecast.